In the do now, we talked about sodium and chlorine. Cations are formed when they have positive charge, and sodium, since it's in that first column, wants to form a positive oxidation number. So this is a cation. Sodium forms a cation, positively charged atom. Chlorine wants to grab an electron, and the electrons are negative. So chlorine is going to be an anion and have a charge of -1. So now that chlorine has its 8 electrons in its outer shell, it's happy. Sodium has 0, it's happy. Then what happens to the two together? Well, it has 0 electrons in its outer shell, but it's positively 1 charge. It's charged. Chlorine has 8, it's happy, but it has a -1 charge. So write this in your notes, left-hand side. What force pulls and holds the ions together? And while you're writing, while you're making a guess, what do you think? Anybody have an idea of a guess, maybe? What? Yeah? There's an invisible force that's everywhere in the universe. Well, gravity's one of them. There's 4 forces. Gravity's one. This is the one that makes us stick together. It makes, well, close. It has to do with electronegativity. It has to do with electrons, and it's very close. It's actually the electric force. That's why electronegativity. So the answer on the right of your notes is ions are held together. They're pulled together by the electrical force. And you want to have that in your notes, because that electrical force, I mean, think about it. Gravity is holding everybody on the planet, and if you're tired, you even want to lay down and get even more towards the ground. It's pulling you down. The electrical force is many, 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 many millions times stronger than that. And that's what's keeping all of our atoms together in molecules and in ions. Well, in ions specifically, because they're charged and they're being pulled together by this invisible force called the electrical force. But it's real, and it affects everybody. Anybody need more time on the notes? Everybody got it down? One more time? Okay. You good? All right. So what happens, unlike molecules that you might just have H2O and then it's just sitting there and it's happy, it's H2O, it's going around in water, there's H2O, water vapor in the air right here. Got a little bit of H2O coming off my forehead because I'm walking around a lot. But sodium and chlorine, they form this array where it can just keep going and going. What's the pattern that you notice here? I want you to look at this and see if you can see the pattern. There's a chlorine that's negative. Right next to that is sodium, that's positive. Then chlorine again, negative, then positive. In fact, if I go anywhere in here, I'll just pick a random spot. This sodium, positive, it's surrounded by 4 negatives. The chlorine, negative, it's surrounded by 4 positives. So this makes an alternating array of positives and negatives. But again, like I showed you those molecular things, chemistry happens in 3 dimensions. So more accurately, there's a 3D view of what's going on in a salt crystal. Okay? Let's say the green here is chlorine. It's right next to a sodium, and a sodium, and a sodium. And the sodium here has chlorine, 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 and a chlorine in front and a chlorine in back. So in 3D, all of the negative charges are surrounded by positive charges, and all the positive charges are surrounded by negative charges. And that's what builds up this pattern. And it has a very special name in chemistry. It's called a crystal lattice. That's the name of this structure. Okay? So crystals can keep growing and growing and growing. I've seen salt crystals that are literally 5 feet tall. And I'm sure there's even bigger ones. So even though these are happening in really small, they can group together in whole large numbers, but they always do it in this orderly pattern. And this pattern is called a crystal lattice. So for your notes, we're going to talk about cubes. Because when you look at it, if you look really carefully at salt crystals, they look like cubes, right? The question is, why does salt look like a cube? So write that on the left side of your notes. Why does salt look like a cube? And it really has to do with that arrangement of trying to get a positive and a negative and a positive and a negative. And that forms a structure. This is new vocabulary for you, so I want you to write this down. Its ions form this 3D structure, and the pattern is called a crystal lattice. That's the most important part of this answer. It forms a crystal lattice, and a crystal lattice, when you build it up, is cubic. It looks like a cube. Sort of like Legos. You put Legos together, they form up and you can make big cubes out of them. Important thing is it's formed like a cube because the ions form a pattern called this crystal lattice. It's a new word for you, new definition of a term. Ions form crystal lattice structures, which is just alternating positives and negatives in 3D. All right, everybody good for the next slide? All right, cool. So overall, compounds that are ionic, unless they're polyatomic ions, they're usually neutral. What does the word neutral mean? Has no charge. So it's neither negative nor positive. So if it has an overall charge of 0, in order to get an ionic compound, the positive ions have to cancel out the negative ions. All right? So that's what we're going to do a little bit, is show how these cancel each other out. And you don't need to write this in your book. I just want, or in your notebook. I just want to show you. Potassium is positively charged. It's in the first group. Bromine is negatively charged. It's in the 7th group. When the negative and positive go together, they form a compound called potassium bromide. Remember, you change the last part of the bromine of the one that's negative into IDE. Instead of bromine, you would write potassium bromide. You leave this the same. That's just to write the element for the first one, for the cation. The anion, you change to IDE. And that's how you name